We are starting the third session is Construction and Demolition Waste Management 2. In the session chair, Dr. Karademir.
Yes. Welcome to this session. My name is Karademir. I would like to basically be session chair here now for this time. And first of all, we will start our presentations with an initial paper listed in our program. That is influence of walnut shell waste usage on the shear strength characteristics of fine-grained soils. So is there anyone available to present this paper in this session?
Hi, everyone.
Yes, first of all, can you please introduce yourself a little bit, just a little minute, small information about yourself, what are you doing now, what's your position, like that, and later you can start your presentation immediately.
Okay, my name is Gençdal. I continue my doctorate at Yıldız Technical University, Civil Engineering Faculty, Geotechnics Department. At the same time, I'm still working in the Civil Engineering Department of Istanbul Kültür University.
Okay, that's fine. Now we can, I think, start your presentations. Thank you very much for participating in this valuable event.
Dear participants, welcome to the Fifth Graduate Waste Management Symposium. My name is Gençdal.
Can you see?
Yes, I can see your video. And I can hear your sound.
Okay,
but now the screen is black at this moment.
Yeah, it's black. 1 minute, please. I will try again. I'm sorry for this.
No problem.
Can you see now?
Yes, I can see your presentation screen.
Okay, I'll start. Okay, now it's okay, right?
Yeah, sure.
Okay.
My name is Gençdal. I continue my doctorate at Yıldız Technical University, Civil Engineering Faculty, Geotechnics Department. At the same time, I'm still working in the Civil Engineering Department of Istanbul Kültür University. Today, I am going to present our paper called The Influence of Walnut Shell Waste Usage on the Shear Strength Characteristic of Fine-Grained Soils. Through my presentation, I am going to mention the aim of the study, the material and methods used to conduct this paper respectively, and finally, I am going to give the conclusion and results. Let's get started with the explanation of the aim of the study. Nowadays, the world is seeking solutions to the problems of rapidly decreasing natural consumption and production resources, increasing waste and decreasing waste storage areas. This problem leads to researchers to focus on the recycling or reuse process of materials. In this context, this study deals with the investigation of all herbal resources statistically reported by Turkish Statistical Institute and the evolution of the reuse process of these natural herbal wastes. According to Turkish Statistical Institute report for 2019, there are 11,251 bearing and 10,004 non-bearing walnut tree crops in Turkey. Besides, the walnut production amount is measured as 225,000 tons. This production process results in the presence of approximately 112,500 tons of shell waste. This huge volume of waste is used in agriculture, cosmetics, furniture, heating by industries. However, the consumption volume of these materials has not reached the production volume until now. In the context of this study, this additional walnut shale waste was used to improve the kaolin soil. In the context of study, as the main material, a white-colored soil with high plasticity obtained from Kocaeli, Turkey region was used. Experiments have been carried out in the laboratory to determine the geotechnical properties of the soil. Sieve and hydrometer analysis, pygmometer test, and plastic and liquid limit test were performed to determine the soil consistency. As a result of the experiments, the soil class was determined as high plasticity according to the Unified Soil Classification System. In addition, as a result of XRD analysis on the soil, 89% kaolin, 3% light and matte morillanite, 4% feldspar and 4% quartz minerals were found in the soil. If you look at the reason of choosing this kind of the soil type, fine-grained soils are considered as problematic soils because they show low shear strength under loading conditions and high swelling tendency under unloading conditions. By the way, within the scope of this study, the effects of walnut shale waste on the strength of these soils that need improvement were investigated. In order to examine the effects of the amount of waste walnut shale on the shear strength of fine-grained soils, soil samples were prepared by adding pure material in various proportions. For this purpose, the waste walnut shale 3 or 4 centimeters in diameter, used as an additive material, was broken with a hammer by placing the soil into a fabric bag, and its dimensions were reduced to 4.75 millimeters to 0.075 millimeters. In order to examine the effect of waste walnut shale on strength, test samples were prepared by adding pure kaolin and waste walnut shale powder to the kaolin material in different proportions. New soil samples were prepared by adding 5% and 15% of the waste walnut shale by weight of the pure material. The relationship between maximum dry density and optimum water content of the samples was determined by performing standard compaction tests, considering the granulometer, the waste walnut shale waste added to the soil. Here, the relationship between the maximum dry density and optimum water content determined by the standard compaction test of all samples are given in the table and graphic. In order to examine the effect of the amount of waste walnut shale and the waiting time on the shear strength behavior of the compacted soil samples, unconfined pressure tests were carried out. Only compaction test was made for 5% waste walnut shale. Due to pandemic period we are in, unconfined pressure test could not be performed. In order to determine the effect of the amount of waste walnut shale, 15% additive rate was examined. In order to determine the effect of waiting time, 0 and 7 days were examined. All of the samples used in the unconfined pressure test were prepared by the same method. The sample which passed through the number 200 sieve during the sample preparation stage was kept in the oven for 24 hours and was expected to lose its temperature after being taken from the oven. The soil was compacted at the optimum water content and dry density values found by the compaction test by adding different amounts of waste walnut shale and kept in the desiccator until the beginning of the experiment. For the unconfined pressure test, 3 samples were taken from a compaction mode. The unconfined pressure test result on pure kaolin compacted at optimum water content were found to be an average of 172 kilopascal for 0 days and 162 kilopascal for 7 days. The results of the unconfined pressure test of the new mixture, which was 15% waste when not shells were added to pure kaolin, were found to be 215 kilopascal for 7 days. For 0-day evaluations, the failure results of pure kaolin is clear. Due to the pandemic period, there is failure results for the amount of 15% waste when not shelled for 0 days for now. For 7-day evaluations, the failure results of pure kaolin was 162 kilopascal on average. The failure result of the new material prepared by adding 15% waste when not shelled was found to be 215 kilopascal. Considering the test results of the new material prepared by adding 15% waste when not shelled and pure kaolin under unconfined pressure test, the increase in the amount of walnuts caused an increase of 25% in strength. The 0 and 7-day test results of pure kaolin are very close to each other. A decrease of 10 kilopascal was obtained in the undrained shear strength values for the 0 and 7 days. Although this value is not a serious loss on the sample basis, no increase in the strength of pure kaolin has been observed over time. The effect of walnut shell waste amount on the compaction and shear strength behavior of fine-grained solids was investigated. The samples were prepared as pure kaolin and kaolin with additive. Compaction and unconfined pressure tests were carried out on the prepared samples. According to the compaction test results of pure kaolin and kaolin with additive material, the increase in the amount of walnut shell waste placed in the pure material decreased the dry density and optimum water content values of the main material. Unconfined pressure tests were performed on 9 samples in total. Tests were carried out considering the amount of walnut shell waste and breaking days. According to the test result of pure kaolin samples, 0 and 7-day strengths are obtained the same. According to the unconfined pressure test results of pure kaolin and kaolin additive samples, the 7-day strength of the wheat additive samples are 25% more than the 7-day strength of the pure samples. As a result, comparisons between pure kaolin and kaolin with additive samples have shown that walnut shell waste materials can significantly improve the strength of the kaolin. The application of the proposed new method has led to a decrease in the unit weight of the soil and an increase in the strength of the soil. Thanks for your attention.
Thank you very much. It was a very interesting study. And now I think if there's a question from the audience, we can continue with the questions unless you have something to say or to add your presentation. Is there anything else you would like to add or you would like to mention else? Okay, I think there is no question from the audience. So we can continue with the next presentation. That is the effect of aggregate sludge waste on durability properties of cement mortars. Who would like to present for the, okay.
Hello, I'm here.
Yes, welcome. First of all,
Welcome.
just introduce yourself a little bit, just a minute, and later you can share your screen and start your presentation. Thank
Okay. First of all, I try to share my screen. Did you see my screen?
Yeah, sure.
Okay.
Can you give some information about your background and what are you doing now? Something like that.
Okay, thank you. My name is Özkan, and I graduated from Yıldız Technical University, Mechanical Engineering and Civil Engineering Department. Now, I'm a PhD student. My advisor is Associate Professor Dr. Kabay. And now I'm working for Aggregate Concrete Company as a special product sales chef. Today, I will try to explain the effect of aggregate sludge based on durability properties of cement mortars. Me, Dr. Kabay and Musaoğulları are conducted this experimental study. Let's begin with the purpose of our study. Waste management is a universal issue affecting every single person in the world, and the global waste generation is estimated to be more than 2 billion tons. Of course, our experimental study purpose is to utilize waste materials. Also, my company, one of target of my company is utilize waste materials. Collecting waste materials is the first step of this. Then stocking waste material is the second step of that. But for using waste material, for utilizing waste material, there is an industrial area is necessary. So, Turkey, one of the famous country to produce concrete and to produce cement. It means that we have lots of aggregate quarries. So lots of aggregate quarries waste material. To sum up, concrete is one of the most used materials in the world, and the utilization of waste materials in cement, mortars, and concrete is one of the preferred methods by the researchers. This study investigates the utilization of washing aggregate sludge in cement mortar composites. After that, I will say as a washing aggregate sludge as WAS. So what is WAS? WAS may be defined as a sealed clay waste that is generated in the classification of sand or gravel. The generation of WAS is a significant issue in Turkey. As I said before, there are lots of aggregate quarries and there are lots of aggregate quarries waste material, but most of the waste material is sent to dump sites without being any utilization. And now I will try to explain our origin that we used in this experimental study. We obtained washing aggregate sludge from the Aggregate Concrete Company's quarry. And this quarry is located in Istanbul, European side, especially in Gençdal location. As you can see in the picture, this quarry has a really good mirrors. The origin of these aggregates, the chemical composition of this aggregate is a silicium dioxide, so we can call this aggregate sandstone. Due to this chemical composition, and due to left side you can see the dikes, due to these dikes found in quarry under investigation, and due to the weathering zone, sandstone and weathering zone found in the quarry under investigations, this quarry requires some improvements. There are three main products these aggregate quarries after the process. One of them is a crushed sand. This crushed sand includes silicium dioxide, and the methylene blue value of this crushed is a bit higher. So using this aggregate crushed sand in concrete mix design is not possible. Because of that, aggregate washing system is necessary, and there is aggregate washing system in Aggregate Concrete Company's quarry. End of this system, you can see here, there is a washing crushed sand. It can be used for the concrete mix design, and the methylene blue value is sufficient and very low. But this system occurs a waste material, and this waste material is the filler of this dust with water. It comes to this pool and go to the down of this pool. Then the down of this pool is a waste material. Up of this wall is a clean water, and then clean water comes with the channel to do recycling water stocking area. Here, there's a filter press system. After this process, finally, the waste material means dust with water comes to the filter press system. Then 3 main products occurs outside. One of them is washing crushed sand. Second one is recycling water. It means a clean water that can be used whatever you want, especially we are using for the concrete mix designs. The last one is washing aggregate sludge. It means WAS. This is our waste material. You can see here, this waste material has a humidity, that 25% of that. You can see here, if you want to use this waste material for your experimental study, first of all, you have to dry it. You have to grind it. After that, you can use it. Now I will show you a short video. This short video will explain all process of this aggregate quarries, aggregate washing system, and recycling system. It takes 3 minutes. The language of this video is Turkish, but it's not important because I have already explained all of them. Now we can start. This video prepared thanks to our suppliers, Diesel Turbo. This is the Oyak aggregate quarry. There are 2 concrete plants and 1 aggregate quarry. Crushed sand comes to first loading area. This is not washed crushed sand. And the methylene blue value is a bit higher. Here is the washing system, CDE EVO wash. Final product. Yeah. And we can come to our experimental study. We use this washing aggregate sludge that obtained from the Oyak Ready-Mix Concrete Company, as I said, and we use one type cement, and we obtained this cement from Bolu Cement. This is one of the Oyak company also, and silicon sand. As you can see in the figure, there is the chemical composition of vas and cement. The brilliant point, the significant point of vas is silicium dioxide element, because the range of this silicium dioxide is higher than 50%. And here we can talk about our mix design. There are 3 incorporating methods were used, and their effects on the durability properties of cement mortars was researched in this study by determining the void content, sorptivity, and non-steady state chloride migration tests. And there are 2 different replacement ratio, 10 and 20. First of all, we have performed cement replacement, then fine aggregate replacement, then paste replacement. Totally 7 different mix design we have. If you add up the reference mix design for 1 cubic meter, ingredients is here. And as I said, the previous 3 different test methods we have. One of them voids content in accordance with the ASTM C642, sorptivity test ASTM C1585, and chloride migration coefficients in accordance with the Northeast build 492 we have already performed. Here you can see all results here. The reference mortars have the results is here 14.3. Chloride migration coefficient is here 16.5, and voids content is here 19.2. If you have a replacement as a cement for 10% and 20%, the sorptivity coefficient is getting higher, and also chloride migration coefficient is getting higher, and void content is nearly similar with the reference mortar. For the aggregate, fine aggregate replacement, also sorptivity and chloride migration coefficient higher than the reference mortar, but it is better in accordance with the cement replacement. And also void content is nearly similar with the reference mortar. Finally, paste replacements give the overall best results overall, because as you can see here, nearly 50%, more than 50%, less results, sorptivity coefficients, as you can see here, and chloride migration is lower than the reference mortars, and void contents also lower than the reference. And these are our test results. And also, of course, we can say that void contents have a good correlation, good relationship with the sorptivity, and the correlation coefficient is 0.88. And the similar correlation, we can see that void contents between chloride migration 0.81. As a conclusion, we can say that paste replacements method was found to be the most effective way of utilizing vas in cement composites. The aggregate substitution method in comparison to the cement substitution method provided better results. And also for the paste replacement method, the sorptivity coefficient was reduced by up to 70%. The chloride migration coefficient was reduced up to 7%, and the void content was reduced up to 32% compared to the reference mortars. And we can also say that sorptivity and chloride migration coefficients have a good relationship, good correlation with the void content. And that's all. Thank you to listening to me. The authors, I and Dr. Nihat Kabay and Sir Musaoğulları. Thanks to Mr. Mustafa Uslu, who is the product and quality control manager of Oy Academics Concrete Company. And also we thanks to Mr. Deniz Saravalioğlu, who is the OHS Environment and IMS manager of Oy Academics Concrete Company. Thank you for listening to me.
Thank you for your presentation, Hakan Özkan. Do all participants, do you have any questions or comments? So we will continue with Tanay Karademir.
Thank you very much. Sorry about that. There was a network problem.
You're welcome.
It was a nice presentation. I think you finished, and it's the time for questions. Is there any question from the audience about your presentation or study? I think no. Thank you very much for your time. And the next question belongs to me. And my presentation is about lime stabilization of Clayey landfill baseliners, and in which we are going to discuss especially consolidation behavior and hydraulic properties. My name is Karademir. I work at Istanbul Bilgi University in Civil Engineering Department, and my research is mostly in geoenvironmental area, in between geotechnical and environmental engineering. And first of all, I would like to show a brief outline for today's presentation. I am going to start with introduction and the motivation of the study, and later I will introduce the materials used in the experimental program. We will see the testing device and the equipments we have used. And additionally, we will continue with the experimental findings and results, in which we will discuss deformation readings with time, volumetric compression and loading, consolidation design parameters, hydraulic properties, and later through the end of the presentation, there will be a comparative analysis and comparison in the finding of experimental program, and later we will conclude. And briefly, lime stabilization or lime soil treatment is a chemical process in which lime is mixed with in-place separate soil, and later lime react with clay particles in the soil to provide cementitious matrix. In this perspective, lime has been used as a modifier or binder in the area, and the treatment of clay, especially having high plasticity, will result in reduction of the plasticity index, and thus the clay will become possessing less affinity with water and to exhibit substantial volume changes such as dilation or contraction. And in engineering, the improvement of engineering design properties of a soil in geoenvironmental area must be satisfied for the project requirements. This is called soil stabilization in this perspective. And the design of landfill baseliners, including a clay layer, as a water-resistant impervious layer, requires a neat engineering approach. Considering consolidation behavior and hydraulic properties of the clay. And for safe and stable design of the baseliners, we need to reduce the consolidation settlement in clay when it is subjected to waste load. And this is the materials we have tested during experimental program. The clay soil used is bentonite clay selected in the study, and the lime mixed into this clay, the stabilizing agent, and the composition of the lime used mainly composed of calcium that reacts with the water in the air to provide calcium hydroxide and leading to amorphous material. And those are the pictures at the bottom, as you see, for the materials used in the study. And this is the testing program. A series of consolidation tests were performed in the study at different lime contents, 0%, 10%, and 20% lime added into a bentonite clay in the experimental program. And the results of the consolidation tests were used to determine consolidation engineering parameters, including coefficient of consolidation, compression index, recompression index, and coefficient of permeability for assessing hydraulic characteristics. The test specimens were having dimensions 6 centimeter in diameter and 2.5 centimeter in height, and that were placed in a stiff metal ring between two porous stones. And each test continued about 6 days with a sequential incremental load of 10, 20, 40, 60, 80 kilograms successfully. And each load increment was maintained 24 hours. And vertical displacement were measured every day at different loading conditions. And this is the testing device we used, automated consolidation cell, and a linear variable differential transformer LVDT was used to measure the vertical displacement to evaluate deformations, and the displacement readings were recorded into computer. And I would like to briefly mention about the theory and calculations. The following theoretical methods were used in order to define consolidation parameters, such as compression index, that was the slope of E versus log sigma prime curve, and the compression index was also defined and determined. Additionally, we calculated coefficient of consolidation CV using the Taylor's method, as you see in the equations. And hydraulic conductivity properties were also determined based on the Terzaghis one-dimensional consolidation theory using this equation. And here are the deformation readings with time. And as you see, deformation readings are shown at different loading conditions. Adding lime into the soil will basically benefit the reduction of the settlement in the soil. And now we see void ratio versus effective stress graph in order to understand volumetric compression due to loading. And here, the compression and recompression stages are evident in the curves, as we have discussed. And we see that the behavior is basically elastoplastic. So some part is recoverable, and some another is permanent. So for the recoverable part, we defined CR, the compression index. For the plastic stage, we define compression index. And additionally, unloading and reloading stages were performed. And here are the results of the experiments on the comparative analysis of experimental findings. As you see, addition of lime has resulted in the decrease of compression index, decompression index, coefficient of consolidation, and permeability. And here are the values. As you see, the compression index has reduced from 10 to minus 2 down to 10 to minus 5. Similarly, CR, the compression index reduced from 10 to minus 3 to down to 10 to minus 6. And so the substantial decreases in the values of CRCC is due to adding lime, so that has a positive impact. And also, hydraulic coefficient of permeability hydraulic properties shows a reduction. This is good for enabling isolation or insulation. And the findings of the experimental program demonstrates that the lime stabilization of clay soils will result in the reduction of settlement at the permeability properties. So, for safe and stable design of the baseliners containing clay, will benefit the project. And reduction of hydraulic conductivity, correction for permeability will result in the isolation of the system. Thank you very much for your attention. Okay, I am done. I have finished. We can continue with the next presentation.
Hello, can I start, Mr. Chair?
Yeah, sure, continue.
Thank you. I'm sharing my presentation. Okay. Welcome, dear guests. I am Özkan from Shear Technical University. Now I am working at Geotechnical Division in our Civil Engineering Department. In fact, my point of interests are soil improvement techniques, artificial ground freezing, soil foundation interaction, and like that maybe pile foundations. Although my real point of interest in geotechnical engineering, today's subject is related with material properties. We try to reuse of waste flat glasses, waste window glasses within the glass foam insulation material, production of glass foam insulation material. It is a part of our TÜBİTAK project. It is so detailed project also, TÜBİTAK 1005 project. And this type of projects is related with the domestic production of export materials. And we know that we do not have any production of glass foam material in our country. And we try to, as an alternative product, as an alternative material. It's a content of my presentation. First of all, I would like to define the problem about the insulation materials and then scope of study. I want to give some statistics about the waste glass materials within our work. And then literature, the critical point in the literature. And I will list the materials, our raw materials, foaming agents, and the production method. It is the subject of this study. And maybe we can talk about the mechanical properties. And our foam glass material has additional properties if you compare with its alternative insulation materials. And I will list the, I'm going to list the conclusion of this study. Harmful fire accidents caused by the ignition of insulation materials used in coatings create loss of life and property. And I gave the two different examples from one of them London and the other one from the Istanbul. And we know that the insulation materials covered or maybe mounted at the outside or maybe the inside interior of our buildings, it creates fire accidents many times. And I give here at the bottom right corner, I gave the four well-known insulation material. First one is the XPS or EPS. These are petroleum-based insulation materials and so weak against the fire effects. The second one and third one, these are glass wool and the rock wool respectively, and these are also strong enough against the fire. However, if this type of insulation materials are subjected to water directly, they can lose their original behaviors and properties also. The last one is our foam glass material. And these are the scopes of our study. First one is defining the details of foam glass production process by the way of waste window glasses. And the second one is obtaining a multi-purpose material that can be used against heat, sound, and water at the same time in residential and industrial structures. Third one is explaining the high capacity mechanical properties and identifying the unique architectural element. It is maybe our additional property. And it's a little bit statistics from literature. If we focus on the European countries at the beginning of 21st century, their recycling amount can be reached up to the 75%. But in our country, around same times, our recycling ratio was around 23%. But after around 10 years or 12 years, our recycling production or the amount of our recycling ratio decreased around 5%. Also, our waste material are increasing, but we must recycle them in suitable properties, suitable materials also. If you search the literature, also we can find many foam glass materials with different raw materials, different forming agents, or different mechanical properties. But this point is so important. The glass foams in the literature are not suitable for mass production in industry. All of them, many of them, are generally produced for laboratory scale specimens. And these are not suitable for industrial production. We try to produce big scaled foam glasses in our project. These are materials, and we use two different raw materials, and these are glass powders. The first one is industrial glass powders, and you can directly buy this glass powder from company, from private firm, and we call it as a type 1 glass powder. It is type 2 glass powder, and we took our waste glasses in our university, and then these are subjected to mechanical broken processes and grinding or the crushing processes, and it is the type 2 glass powder. And these are our forming agents. We totally used 10 different forming agents, and 9 of them are given here. Calcium, these are calcium oxide, and dolomite, calcite, and glycerin, and different types of coals. And these are dust of oak coal, for example. And it is a production method. First stage is the production method is the mechanical processes. As I said before, these are the production of type 2 glass powder. We take our broken glasses from our university and then broke them into the smaller parts by hammer. Then we put into them into the Los Angeles abrasion machine. As you know, that Los Angeles abrasion machine, we generally use it for the concrete or asphalt pavement elements to determine the abrasion value also. And then final stage is required the grinding process also. And after these processes, we pass to the sieving stage, and it is raw material also, only waste glass powder, and we sieve it up to the reach up to the also 100 micron level, and then mixing processes coming. Raw material and the forming agents were mixed together. The molding stage, I think that it is the most important stage, the molding stage of the production method. We also produced 3 different elements. One of them plate elements to exterior or interior covering of our buildings. Next one is the architectural elements for production of aesthetical elements, and the last one is the fitting parts for industrial applications. In the plate molds, first of all, we used a vermiculite type of molding material. You know that vermiculite is the type of clay element, and these plates or these molds are produced with the compaction of these vermiculite grains. And also we produce different size of elements. For example, it is 10 centimeter unit length of cubic element, and it is the 1 meter to 1 meter big scaled element. And in the next stage, we use the plaster material as a plate, as a production of plate. And then steel, standard industrial steel are used. And finally, we decided to use a stainless steel. It is a special product of molds for 50 centimeter to 50 centimeter unit volume also. And then sandblasting is applied to the stainless on the stainless steel material, and then we use a paper type of material to easily take the specimens inside the molds also. In the second stage, architectural molds, similarly we use the vermiculite type of molds at the beginning of this production stage. And then silicone, foam, and plaster type of molds are used. And these are the our final products. First two one also sketch. These are our hope to application at the exterior surface of buildings. And these are real products. These are foam glass elements for the near of windows or doors or any exterior aesthetical members. The last stage of the molding is the fitting molds, and we use refractory ceramic material for design a unique molds in that case. And these are the final products. Also, we produced fitting elements, and we produced foam glass materials for the outside of the pipe elements for industrial application. As you know that some firms with using a high temperature of maybe cold, high temperature of hot, or maybe a minus temperature of cold degrees to within their piping systems, and these fitting elements, this fitting insulation is required. It is essential also. The next stage is the sintering and sizing processes. As you know, that sintering is the other name of heat application. We tried 10 different maybe heat processing or heat diagrams inside different type of ovens. And after completion of forming up to the required thickness, and then sizing stage are started also. We use different type of saws to sizing of our original members. Totally, we produced more than 120 different samples, but many of them are not effective, as you see in here. These are or these elements have so amount of maybe density value, or their thickness is not enough for the forming application. And these are final products. We selected 6 different glass forms as a final products, and their void behaviors or the bubble properties are given here. 3 different materials are given here. For example, it is K1 and the bubble detail of K1 elements. It's K2 and the bubble detail of K2 elements. It is the K3. And in the first group, we use a dolomite and the calcite type of forming agents. And these white colored specimens are T1. It is industrial glass powder. And the brown colored glass forms are our product glass powder. And in the other combination, we use the coal inside it, or coal powder. And in these type of specimens, we use the glycerin, and also their combinations. It is also a critical point. And let's talk about the mechanical properties of our foam glass materials. And these 6 different foam glass materials, final products, have superior mechanical properties, and their density change between 180 to 256 kilogram per cubic meter. And this density range can be reached up to the 400 kilogram per cubic meter around worldwide. And water absorption capacity in terms of surface absorption, it is around 0. And it can be used against as a waterproofing at the surfaces also. And the water absorption capacity, for, according to immersion test, it can be reached up to the 3.5 kilogram per square meter or cubic meter according to these TS standard. But important one is the surface absorption capacity. The temperature insolation delta T is changed between 9.6 to 11.1 Celsius per centimeter. And sound insulation, we can try a 20 to 30 decibel of sound insulation level. And also all of the specimens, all of these 6 different specimens have A1 class waterproofing certificate. And the thermal conduction coefficient, lambda, it's changed between 0.03 to 0.05. The maximum level, the maximum range of this value is given around 0.06 inside this standard with the unit of watt per meter Kelvin. And the compressor strength, it is maybe the unique point of our material. The compressor strength value can be reached up to 1.2 megapascal. It is also incredible value because it is an insulation material. If you compare with it, the XPS, EPS, or rock wool, glass wool, any type of insulation material, it is so high level, and its strain can be reached up to the around 25% with under this amount of compression strength. So some of our materials are brittle, some of our materials can be classified in ductile elements. And freeze-thaw resistance is okay. There is no problem with the freeze-thaw effect. Shortly, I give an additional properties in here. Colorful production can be obtained if you add a colorful dust, colorful powders inside your mixture. You can directly provide a colorful production. And their surface is colorable property. Plastic color or oil color or spray color, any type of color can be applied directly on the surface. It has pervasive property. What's the mean of that? The mortar of plaster, any type of plaster can be directly applied in its surface because it has space, some also high amount of friction resistance on the surface also. Easy to shape, and maybe the most critical point of within this conference, it has, and our materials have infinite recycle possibility. It is so important. And these are conclusions. The raw material completely contains waste glass, soda lime glasses, window glasses, or wet flat glasses. These are our standard glasses. And natural, cheaper, and environmental friendly forming agents were used. Sintering technique was directly used to the dry mixture, and dry mixture, it is our another unique point, and operating costs are dragged down since relatively low temperature was applied. Our peak value around 8.50 Celsius. It can be reached up to the 1.2 thousand degrees in other production processes. And final products have superior engineering properties. Industrial scale glass forms were produced successfully. And also national and international intellectual property rights have been acquired with patent appeals. All rights have been reserved also. Maybe the another important critical point, the price of export product of glass foam for 1 cubic meter, it is around 4,000 Turkish liras in its current price. Cost of our product for 1 cubic meter, it changed between 150 to 300 Turkish liras. There is high difference between them because we use the waste glass powders and natural rocks as a forming agents. Thank you.
Thank you very much. It was a very interesting study. Is there any question from the audience? I think there is no question. Okay, thanks a lot. I think we are coming to the end of this session, and we will finish. Thank thank you for your very valuable contributions for this very valuable event. And we would like to see you in the next conferences. Thank you so much.
Thank you.